the vast majority of you are not. So I'm going to probably bore the database analysts a bit because they've heard a lot of this stuff, but I'd really encourage those of you who aren't database analysts to tune in and listen to what we're doing around data management. Okay. I just threw this slide up because this is actually Oracle's new mission statement, which you may have not seen, I don't know. But the interesting thing about it is Oracle's corporate mission now is all about data. And it's about what our customers are trying to do, which is unlock value from their data. Not only via databases, but also via things like our business applications, et cetera. And hopefully, by the end of this presentation, you'll understand what we're doing in that space. It's more than just about databases. We work in 3 core areas in the database group. And I think it's really important to understand that because a lot of people get all excited about cloud and they think, well, all we're doing is cloud stuff. But on the cloud, we are running our core database software, the same core database software that customers are running on premises. It runs in our cloud, and all the innovation we do is available everywhere, right, on premises and in the cloud. So we are doing a lot of investment just to make sure we continue to have the best database management system out there. Number 2, for the last 10, 12 years, we've been working on this technology called engineered systems. The premier engineered system at Oracle is something called Exadata. Have you all heard of Exadata? I'm just curious. Well, the database guys are laughing, but I don't know if the other people know about it. Okay. Anyway, it is this platform that was optimized for running the database for all workloads. Since then, we have a few other engineered systems. The biggest other one is the recovery appliance. And the big thing about engineered systems is that this is the best platform for running Oracle databases by far, which our customers have figured out on premises. And we have moved that technology into the cloud. And again, it's one of the best reasons, if you're running an Oracle database, why do you want to run it in Oracle's cloud versus another cloud? It's because we're using this Exadata optimized infrastructure that gives Oracle better performance, better scalability, better reliability, et cetera, in our cloud. You can run Oracle in other clouds, but you won't get an Exadata. And then the last initiative is autonomous database. It's all about cloud. It's all about the self-driving database, just like the self-driving car. And I'll talk about that as well. Okay, I wanted to start with this because I wanted to sort of explain at a pretty high level what's the core difference between what we're doing strategically versus Amazon, which is obviously the big gorilla in this cloud space. And Amazon is out there, and let me see where we are. Oh, okay, let's get this next slide. Okay, Amazon is out there and telling developers about this thing they call purpose-built databases and why they're such a great idea. This is Amazon's slide that they presented at, I think their reInvent conference or whatever they call it. And it looks pretty good. It's like they have this wide array of data management tools that are especially good at different jobs. But when you drill down in it, the first thing you notice is they have a lot of these non-SQL databases. DynamoDB, DocumentDB, Quantum Ledger. And the interesting thing about these databases is they all have these APIs that Amazon has defined that are proprietary. And if you can get a developer to write an application to these APIs, there's only one place your application is ever going to work. It's only going to work on Amazon. So Amazon has a very clever lock-in strategy, number 1 here. Use our proprietary APIs, never run anywhere but Amazon. Number 2, the other reason it's bad for developers is that when you build an application, it's hard to envision sort of where that application's requirements are going to go over time. So if you say, yeah, today all I need is a DynamoDB, I'm just doing sort of key value lookups, I don't need analytics and any of that stuff. And then, of course, a few years later, or a few months later, your business unit says, hey, I need some reports, some analytics, and it's like, well, I can't do that on DynamoDB. It's like I have to rewrite my application and put it on a real database, like something on Aurora, a SQL database. And so developers, they don't understand the future. And so you get sort of wedged into this product that doesn't really take you where you want to go. And finally, Amazon has this notion that oh, when you build an application, you shouldn't just use one kind of database. You should use all these databases for different parts of your application. And sounds really good until you think about, well, how do I do analytics? My data is now fragmented across 7 different databases. Each one has a different incompatible API. If I have an analyst and I want to do some reports and join data between 2 databases, it's impossible. If I want to do transactions, I want to do updates coordinated across multiple databases, forget it. So the strategy, although it looks great, is a really bad idea. And my favorite one is this new quantum ledger database. This is really cool, blockchain tables. Well, who has an application where you want all the data to be in blockchain tables? I can understand maybe the audit trails or things of that sort might want to be in blockchain tables, but the whole database? And the performance of blockchain tables, of course, is horrible because blockchains are inherently much more expensive to update, et cetera. So this strategy is sort of out of control. And so what we are doing is totally different. We're saying, all these different kinds of requirements can actually be satisfied by one, we call it a converged database. The original relational databases of 30 years ago have evolved quite a bit. They're not just about relational data anymore. They support JSON, key value, of course, trivial subset of relational databases, graph, spatial, etc. So the SQL standard, which is this open SQL standard that lots of vendors work on together in a standards committee, has been extended over the years to provide an API, SQL API, that can go against all your data, whether it's structured, semi-structured, etc. So this is a great open standard API that we support in Oracle, okay? And we give developers what they want. They can manage all the data that they have in their organization. They can use open standard SQL. And if at some point they don't like Oracle anymore, they can move their application pretty easily to another SQL database. They can do transactions across all this data. So if you're a developer and you have different kinds of data types, there's no complicated two-phase commit or even worse to make that data work. It just worked. You just say update here, update there, commit, you're done. And not only do we support all the different kinds of data types, but we support all the different use cases, all the different kinds of workloads, from transactions to analytics to everything in between. You can do everything on one database. And the other good part about it is, the developers get what they want, but the operations people, the analysts, get what they want. The data is not fragmented, so if I'm an analyst and I want to query across all my data in my application, it's easy. I run a SQL statement, I'm done. If I'm an ops person and I want high availability, and I want DR, and I want great security, right? It's just there. You don't have different levels of quality of service that you get in all the different Amazon databases. You don't have totally incompatible security systems that you get with Amazon's databases. So this is a much simpler strategy, a much simpler way for developers to go. And I'll talk a little bit later about some of the other things we're doing in this space. But I just want to start with that. The Oracle database is now evolving even more rapidly than the past. We are a much more agile development organization. We're coming out with a new release every year, and we've named the releases by the year it comes out. So 20C is the new version of the Oracle database that is just sort of starting to roll out in our cloud and eventually on-prem. And what you'll see in this release is a continuation of this strategy. So we talked about Amazon's quantum ledger database, a really dumb idea, right? So what is the right idea? Well, the right idea is just extend SQL, Oracle SQL database. So if you have a table that's like an audit trail and you want you want the ability to have the equivalent of a blockchain table, just do that. When you create a table in 20C now, you can say, make this table a blockchain table. We will use the same techniques the blockchain guys used for making sure that data is tamper-proof and append-only table, etc. But it's just a standard SQL table. So if I'm a developer and I want to run a query that joins data in a blockchain table with a data in a non-blockchain table, it's just a standard SQL statement. Nothing more, right? Why do I run another cloud service that just has blockchain tables?
Stephanie
Makes no sense.
I'm
AutoML.
going to teach you.
So one of the best kept secrets about Oracle is that we have machine learning data mining algorithms built into the database for now about 15 years. We've been modernizing these algorithms, as new popular algorithms come out for a long time. And one of the problems we have in this space is that there aren't a lot of data scientists out there who know how to create machine learning models. So in 20C, we have this new capability called AutoML, where we can help a business analyst who may not be a PhD in computer science actually build out his own machine learning models for his application. JSON, very popular new data type. Relational databases have embraced JSON. The SQL standards now support JSON as a data type. We have supported JSON and SQL extensions for JSON for many years. In 20C, we're actually creating a new data type. Before, we just used standard character strings for JSON documents. Now we have a binary representation in 20C, which gives us better performance when you're traversing JSON documents than before. And then the last thing I want to mention is this persistent memory technology. How many of you know about Intel's new persistent memory technology? I'm just curious. A few. Yeah, Intel has not done a really good marketing job here. So this technology basically lets you have standard DRAM that is persistent. It can be storage. And so this is a complete disruption of the standard architectures that all databases have been built around for the last 30 years. This is a really important technology, and Oracle Database, in our group, we have a huge development project going on around making sure the core of the Oracle Database is optimized for persistent memory. In 20C, you'll see the first version of this technology where what we call single instance Oracle databases can natively store data in files that are persistent memory files. And then you'll see in later releases Oracle's clustering technology, which today we call Oracle Real Application Clustering, which is a very unique scale-out technology for all kinds of workloads. That technology is also being extended to support persistent memory as well. And I think Jenny might be talking about that project a little bit in her drill down session later today. But this is a big deal. This is one of these areas where if you don't make a big investment today, in 5 years, your technology is going to be legacy. And at Oracle, we want to make sure we are the leading database provider, 5 years, 10 years from now. So we are doing major investments in persistent memory support. Okay, move on. Engineered systems. Big, successful business area for Oracle. We rolled out this technology about 11 years ago. We had the big 10th anniversary party not too long ago. Customers on premises now understand this technology really well. They roll it in and suddenly everything is running faster. Usually 2 times faster, 3 times, depends on the workload. It's very successful on-premise technology. I'm not going to go into a lot of details, but the key idea is that we have a lot of specialized algorithms on top of just commodity hardware that we use to make Oracle Database scale better. The rack scale-out technology just works better in this environment. Workloads like data warehouse workloads that do massively parallel queries run much, much faster in this environment. Transaction processing workloads scale better, etc. Okay. And I wanted to talk about the latest version of this because this is a big departure in technology. So if you look at this little picture on the left that sort of looks like clip art, it's actually pretty important. So Exadata is a collection of commodity compute servers, just Intel servers, connected by a network to a collection of storage servers. And the network historically was InfiniBand because InfiniBand had the best performance and it had this feature called RDMA. With the X8M that we just started shipping a few months ago, we are moving from InfiniBand to Ethernet. So why are we doing that? Well, because after 10 years, Ethernet has caught up to InfiniBand and actually surpassed it. It now has better performance just from a networking standpoint, and it also has RDMA, which is this remote direct memory access technology that is part of the secret sauce of why Exadata works so well for scale-out databases. So in this release, we're moving to Ethernet. The other thing we've done is we've added persistent memory into the storage hierarchy in an Exadata. Customers don't even know it's there, except you get even better performance than before. The other reason we're doing this, if you look at the OCI cloud infrastructure, and most customer networking infrastructures, they're all using Ethernet. Nobody's really using InfiniBand anymore. So as we move Exadata to this technology, Exadata in the cloud can move from being a physical kind of box that you roll into your data center on-prem to also just being a native technology in our clouds. And so you will see later this year Oracle rolling out a new kind of block storage on our cloud. It's not just vanilla block storage, but you'll see Exadata block storage. And what that'll mean is that you can provision Exadata-like infrastructures on our cloud dynamically with the push of a button, as opposed to using physical Exadata boxes. So this is pretty important. And persistent memory is really fast. And so let me show you this. So this slide sort of compares what is the latency for a read I/O